Hi everyone, my name is Mrs. McCrary and this video is part 4, Evaluating Research Data, and this is in the unit of Scientific Foundations of Psychology. So to start with, when psychologists do any kind of research method, they're going to have data after they collect their research. And a lot of times that data is a long string of numbers, and sometimes it's hard to make meaningful conclusions about just a list of numbers, especially if you have hundreds or even thousands of participants in your study. It's just going to be really hard to make sense of all of that. And so there are different things that they use as far as measurement tools to understand their data. And the two types of data analysis, the big broad types, are descriptive statistics and inferential statistics. Descriptive statistics are just measurement tools that help you understand a single set of data. So if I were to test a group of students, then descriptive statistics would just help me understand that group that I tested. So maybe I find the average, or I find the difference between the highest and lowest scorer, or maybe the score that occurs most often. Those are all different types of descriptive statistics that help me understand that single group that I tested. There is also something called inferential statistics. Inferential statistics you would use in a certain circumstance. So you would only use inferential statistics when you are able to make inferences. And so I could only use an inferential statistic if I pulled out a sample. So if I pulled out of a sample of a big population and then I tested that small sample, the statistics I gather from that small representative sample could help me infer things about that bigger population. So let's just kind of go into that just a little bit more deeply. So here's a diagram to kind of help you understand inferential statistics. Inferential statistics would only really work if you were pulling out a representative sample, and then you could make inferences, like I said before. So an example of that might be if I wanted to survey high school students, but I didn't want to survey every high school student. So I would look at the makeup of high school students maybe in a particular building, and I would categorize them alphabetically: freshmen, sophomores, juniors, seniors, and then I'd pick every fourth person in the list of freshmen and every fourth person in the list of sophomores, juniors, and seniors, and then I'd get this representative sample that I could make inferences about the whole population. So if 80% of the students in that sample said that they preferred block scheduling to an 8-hour class day at a high school, then I could say that likely 80% of high school students feel the same. And so I could make inferences about that whole population. This is the same way if you've ever heard just statistics about drug medications, especially like on commercials on TV, they might say like 95% of people will see reduced symptoms after a week of taking this medication. And you might think like, how do they know that this is gonna, how do they know that that's gonna be the same for all of these people? And they know that based on a sample, a representative sample that they took and they tested. And so they can make inferences about a whole population. So descriptive statistics, let's go back to what we're talking about. If we're just looking at just a single set of data, there are all kinds of meaningful tools we can use. You've probably used many of these, and you're probably familiar with them. So measures of central tendency help us look at our string of numbers and help us find numbers that fall around the center, and descriptions that help us understand the middle or center. Then we have measures of variation that help us understand the spread or the distance of our data. And we'll talk about each of these in a little bit more depth as I go through each slide. So if we have a data set that looks like this, maybe we did a memory test, and these were the scores that came back from this memory test. I'd like for you to see if you can remember mean, median, and mode, and I'd like for you to see if you can find these. So go ahead and pause the video and see if you can do that. So what I found is that sometimes this is not very complex for students because they're familiar with it, but sometimes overconfidence gets the best of students, and sometimes what gets them in trouble is they end up flip-flopping, like they flip-flop median and mode. So just a quick refresher, median is the number that falls in the very center of the data set if you are to order it chronologically. It's the number that falls right in the middle. Mode is the number that occurs most often, so most frequently occurring number. And then mean is the average, so you add up all of the values and then you divide it by the number of values that you have. And so here is what you should have gotten. The median, the number that falls in the very center after you order them, so you can see I've ordered them now, is 5. And I just remember median is in the middle of between two highways. The median is in the middle. The mode, the number that occurs most often, is 5. It occurred 7 times in this data set. In the mean, you would have had to add all of these numbers together. You should have gotten 168, and then divided by the numbers, the number of numbers, which is, I think, 31 on this data set. So you should have gotten 5.4. If we were to plot this, it would look something like this. So you can see here were the number of people that took this memory test. You can see these are their scores. So you could have scored 1 to 10 here, and then the most commonly scored score was 5. And so we have 7 people scoring 5, 1 person scored a 1, 1 person scored a 10. And it's kind of creating this really nice bell-shaped curve here. You can see n equals 31. N just stands for your population or your sample size, the number of people you tested. And so we tested 31 people, and so n equals 31. So sometimes, though, this is really typical that you're going to get most of your people falling around the middle or around average, and that's going to be your mode, and it creates this nice like peak in the center. But it's not always that way. So I'll give you an example of a situation when it's not. So here you can see we have different families within a city and their household incomes. And you'll notice that you have lots of families down here. Their incomes are, between $30,000 and $100,000 a year. And then we've got some really extreme outliers. We've got some of these people who have really, 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 really high incomes. So high that they had to put even a break in our little number line here, that they are so high. So what we have here is we've got a situation where we have these really high extreme outliers that are drawing our average household income away from what most people are earning. So most people in this city are earning kind of down here, and then we've got this average of 140,000 because we have our extreme outliers being figured in. So this is something just to keep in mind when you have a situation where you have extreme outliers. It makes your average higher or lower, depending on if your extreme outliers are higher or lower. And so if you were to hear someone say the average household income in this particular city is 140,000, you might think, wow, these, wow, lots of people are earning $140,000, when in actuality, most people, if not the majority of people here, are earning below that. So this is a situation when average doesn't necessarily reflect the whole, because we have these outliers. And so this is when you would also want to take in consideration your median household income, your mode household income, to give you a better picture. So here's what it looks like when you have skewed data. So you can see here was our center, our normal curve where your mean, median, and mode are the same. So it creates this nice peak. But if you have extreme outliers that are really, really high scoring or high earning, it's going to pull your mean higher than what most people are scoring. And so this is called a positive skew when you have some really high outliers up here. If you have some really low outliers who are scoring really low, then that's going to pull our mean lower, and we're going to have most of our people scoring higher than our mean, and that's called a negative skew. You might also have something that looks like this when you're plotting data. If you have 2 modes in your data, so you have 2 numbers that are really frequently occurring, you're going to end up with 2 peaks in your distribution. It's called a bimodal data distribution. Okay, so next we have measures of variation, which help us understand the distance of our data. And if you remember, range is the highest score or the highest number, and the lowest number, and finding the difference. And if we do that with this data set, we would find that our range is 9, our highest number is 10, and our lowest number is 1, and so our range is 9 data points. Now, standard deviation is something you will not have to calculate, so I'm not going to ask you to calculate this from this data set, but it is something you're going to need to know. Standard deviation helps us understand our data set further, and so what you just need to know is what standard deviation is. So I'm going to go back to a distribution of data just to explain standard deviation. Here is just another data set. You can see our mean, median, and mode is 100 in this data set, and then we have some higher scores over here, but fewer and fewer and fewer, and some lower scores, fewer and fewer and fewer to the left. And so most of our scorers on this particular test are scoring right in here around the mean, median, and mode, and that's really typical whenever you are surveying or testing. This is called a histogram. It's basically a bar graph where the bars are really close together, and then you can draw this curve to kind of see the path of our bars in the distribution. Okay, so standard deviation. Standard deviation, just really simply, is the spread, or like how dispersed your data set is. Some data sets are really clustered and close together, like our example of our scores of 1 through 10, and we had lots of 5s and 6s, and those are really clustered close together. Some data sets might span all the way, in the thousands, and so it's going to disperse our data farther apart. And so standard deviation just helps us understand our spread. It's kind of like a distance measurement, like you might think of as like inches or feet. And standard deviation, the way you use this measurement, as you can see, here's a really clustered data set, and here's a really dispersed data set. You can see in each data set there are 6 sections if you were to count them: 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. You just notice that the sections are wider or thinner because the data set is either wider or more clustered together. And so these are actually standard deviations. You'll have these sections that represent one standard deviation, and those standard deviations are just either wider or thinner depending on how dispersed your data is. So let's look at this with a real example. So here's a real example. This example is of IQ scores. And so when you plot, or if you test IQ scores and you plot them, you're going to notice that most people are going to fall around a score of 100. 100 is the average on an IQ test. It's also the score that happens most often, and it's the score in the middle. So we end up with this really nice bell curve when we plot IQ data. You're going to have really few people scoring out here at 145. Really few people scoring out around 55 or below, and so it's just going to create this really nice bell curve. So we can use standard deviation here to understand just how spread apart our data set is. And so here you can see we have those 6 sections. We've got 1, 2, 3, 4, 5, 6. But these 6 sections are 15 points apart. So you can see from 100 to 115, from 115 to 130, they're all 15 points apart. And so our standard deviation for this particular data set is 15 because our equal sections here are all 15 points apart. So that's really simply what standard deviation is. Now, if our numbers were stretched farther and they went into the thousands, then our standard deviation is going to be wider and our standard deviation will be a bigger number. But you'll always have these 6 equal sections. And so just to kind of understand our data a little bit further, what we know to be true is that when we find standard deviation, we know that there will be 68% of the people who are tested will fall 1 standard deviation above and 1 standard deviation below the mean. So you can see that on here. They've marked it for you that 68% of the people in this sample are falling in between the scores of 85 and 115. So just once again, 68% of people will fall 1 standard deviation above and below the mean. Now, if we just went 1 standard deviation above, we could find that 34% of people will be falling 1 standard deviation above, or 1 standard deviation below, 34% of people will be falling. And that's true of any data set. Now, if you go 2 standard deviations above and below the mean, you can see they have it on there for you. They have 95% of the data, or of the people who were tested, fall 95% above and below the mean here. And then we've got this tiny percentage of people who are falling out here and this tiny percentage of people who are falling out here. If we include all of these together, we're going to have about 99.7% of people who are falling in this area here, 3 standard deviations above and below the mean. And so most of our testers, if not all, are going to be falling 3 standard deviations above and below. So standard deviations also help us if we want to know our test score, and we want to know how our test score compares to average. So if you score a 120 on this IQ exam, someone might say you were 2 standard deviations above the mean. That helps you know how far away you were from average, and so standard deviation can do that for you also. Okay, lastly is statistical significance. So when we're looking at research data, when we collect information, we're going to collect information from a control group and an experimental group, and we're going to look at the differences between the data we collected between those two groups. And if the differences are really, really big, then that helps us understand that whatever we did to that experimental group, it definitely made a difference. And so we will say that difference is really statistically significant, that mattered, and that's a reliable difference. If we find that our data is really close together between our experimental group and our control group, then maybe it's not statistically significant. Okay, guys, that was it for this video.